Okay, we have done two trends thus far. We've talked about atomic radius. We have talked about ionic radius. We left off last time with ionization energy, which is the energy needed to pull an electron away, to turn an atom into an ion. Whenever atoms lose electrons, they become a positively charged ion, which we call a cation. There are first ionization energy, second, third, fourth, and so on. What I left off with yesterday is this. You could have a high ionization energy. This means the nucleus has a strong hold on the electrons. Gwyneth, if you were holding on to, say, your phone and you had a strong hold on it, am I going to be able to rip it out of your hands? Probably not. So an atom that has a strong hold is not going to let go. So this is less likely to lose its electrons. Then we have a low ionization energy. The nucleus has a weak hold on the atom's electrons. So Gwen, you are just casually walking down the hallway with your friends. You really don't have a care in the world. You're not worrying about something taking your phone, and someone comes up behind you and just snatches your phone. You were holding onto it very loosely. Is it easier to lose it when you're not holding tight? Sure, makes sense. So these atoms are more likely to lose their electrons and become ions. Now, let's see what you guys remember from the last 2 days. Who's going to be my victim? Joseph. Whether you are or are not likely to lose electrons, can you tell me what type of ion would be the result of losing electrons? I'll give you a hint. Meow. A cation. Cations are positive. If you lose electrons, you're going to have a positive charge because you have more protons now. That is correct. So the trend, your third trend, everybody. Ionization energy generally increases from left to right. And decreases from top to bottom. So the trend looks like this. All right. What this basically means, everybody, and you don't need to highlight this part, just please pay attention. Elements that are over here in this section, they are more likely to lose electrons. So what type of ion would they form? A cation or an anion? Yeah. And atoms over here are more likely to not lose electrons. So you're going to find here in a moment, they're more likely to gain electrons. So what type of ion would they become? Yeah, but all you need to know for this very moment, right here, right now, is this is just about losing electrons, not gaining yet. I'll talk about gaining in a second. But the ones I just kind of scribbled in yellow are more likely to lose an electron or two. So they would become cations. Yeah, Joseph. There's always an exception to the rule, Joseph, but we're not going to glorify that. We'll talk about more of those exceptions when I get to bonding, which is unit 6 and 7. But for the most part, elements towards the left-hand side of the periodic table lose electrons, and elements more towards the right of the periodic table gain electrons. So generally, from here to here will become a cation, and from here, actually not in the noble gases, from here to here will become an anion. And it's all about becoming stable. That's the purpose of having a charge. If you need to get a sip of water, help yourself. Yeah, just pop the door open. Okay, let's get to our final trend, everybody. Electronegativity. This is your fourth and final new concept, and it includes your fourth and final trend. This is the ability of an atom to attract electrons or an electron. You know, everybody brings up an example in school. Nobody does this anymore. I certainly hope not. But you either can take lunch money or have your lunch money taken. Think of it like that. Think of it like nature. You either hunt or get hunted. In chemistry, you either keep your electrons or you lose your electrons. Or let's rephrase that. You either take electrons or you lose electrons. There's got to be one or the other. There's givers and there's takers in the periodic table. Elements that give their electrons up have a very low electronegativity. Elements that are able to steal electrons from someone else, another atom, has a very high electronegativity. So the most electronegative element is fluorine. How would you describe fluorine on the periodic table? Is it more towards the left or more towards the right? Is it more towards the top or more towards the bottom? So, based on that trend, guys, if fluorine is as electronegative as it gets, what do you think the trend of electronegativity is as you go from left to right towards fluorine? It increases. And how about when you go from top to bottom as you get further away from it? Decreases. Now, if you can look at a periodic table, what element is in the bottom left-hand corner? It's native to a European country. Yeah. This is the least electronegative element. Francium. Here's how I remember it. What country has not been that hard to beat in human history? Yeah, France. It has been hard. World War II, they lost twice until the Allies helped them. Even, you know what Cinco de Mayo is? It is not Mexican Independence Day. A lot of people think it is. It's where the Mexican armies fought off the French. And that was a really big deal back then for an army like Mexico. They beat off a European country. That was pretty big. So France is not one. So what I think of in my mind is when I think of francium, I think of weak. That's just me. Sorry if you have French ancestry. It's nothing personal. When I think of fluorine, what is fluorine's symbol on the periodic table? When I hear fluorine, I think F yeah. I think strong. I think like crazy. Fluorine is the toughest. Francium is the weakest. So when you actually do a periodic table, if you can draw out another model for me. We are going to exclude the noble gases. Electronegativity is all about attracting electrons. Why don't the noble gases have to attract any electrons? They're already stable. There's no purpose. They are, why does it keep doing this? I'll just do that. They're eternal bachelors and bachelorettes. So fluorine, right here, is the strongest. And francium, way down here, Fr, is the weakest. And so as you go from left to right, electronegativity increases. And as you go from top to bottom, the electronegativity decreases. So I have some great news for you when you get to study. I see you, Connor. Hold on. The trend for ionization energy is the same for electronegativity, everybody. And the trend for atomic radius is the same for ionic radius. So you guys have 4 trends to remember. If you in your mind can just correlate atomic and ionic are the same, and ionization energy and electronegativity are the same, it should help you out. Yes, Connor. Fluorine is the strongest because it's closest to being stable. It has 7 electrons. It needs 1 more. What would make more sense to you if you had 7 electrons? If I were to draw fluorine here for you, like we've been doing the last few days, here's fluorine. 1, 2, 3. Oop, did that wrong. Hold on. There we go. 1, 2, 3, 4, 5, 6, 7. What would make more sense to you? Gain 1 more electron right here and have a stable second level, or lose 7, go down a level, and have a complete first level? Yeah, it's so close. So it's going to have a very strong attractive force to complete its valence shell because it already has so many other electrons. So it just needs 1 more right there to be stable and become an ion. Yes, sorry. Because they all have 7 valence electrons. Everything in group 17 is highly reactive because they have 7 valence. They just need 1 more. It's kind of like when you're 17 years old and you're like, oh my gosh, I'm almost there. I'm almost an adult. I almost have so much more freedom. It's just the electronegativity is very strong because they're just so close to being stable. They're highly reactive. They need 1 more electron. Yeah. Because there are more protons there. There's a lot more protons. And so the protons are able to pull and try to keep the electrons closer. Yes.
So that's why the electronegativity decreases with higher groups.
Yeah, because you're increasing the number of protons, but you only have 1 electron on that outermost energy level. All right. So these numbers, guys, and I'm going to give you a few values here. They are measured with numbers. Every electronegativity value is expressed as a number called a Pauling. It's named after an American scientist, Linus Pauling. So fluorine, the strongest of them all, has an electronegativity value of 3.98 Paulings. And francium has an electronegativity value of 0.70 Paulings. if you want to write a page number in your book and see some of them for yourself, on page 179, figure 19 has all the values, the entire periodic table, except for the noble gases in the F block, because you really don't need those. Connor, you had your hand up? No? Okay. Now, here's the last thing. And this last thing I'm going to tell you will be it for today's class. And it's going to be a great way to transition into our next unit, which will start on Monday, called bonding. Why is electronegativity important? In a chemical bond, the more electronegative element takes electrons, the less electronegative element there's different ways you guys can phrase this. It makes no difference to me. You could say loses, you could say gives, you can say donates. I don't care. I'll put it all out there. I'm going to say gives, donates, loses. It doesn't matter what verb you use. It's not going to have it anymore. Whether Ben loses his shoes, has his shoes stolen, donates his shoes. Here's the point. He doesn't have his shoes anymore. I don't care what verb you use. So here is what I want to do to finish up class today. We got 15 minutes, plenty of time. I do want to give you guys some time to work on your review in class. Some of you may have been wondering, where do these electrons go? Like when we were doing this, check it out. When we were doing sodium, 11 protons, 11 electrons. I asked you to draw it. Here it is. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then 1 on the outside, a total of 11 electrons. How many valence electrons does sodium have? It has 1. I would ask you guys, what makes more sense to you? Sodium losing 1 electron and going down to the second level, which is stable, or gaining 7 electrons and completing the third level? What makes more sense? Lose 1. So a sodium ion will have 11 protons, 10 electrons. Look at me, or look at the screen. Gone. And it gains a positive 1 charge. Some of you were texting me on the side, like, where does it go? And I hadn't told you that yet. Now I am. So this is a great example I want to do, and I want to talk about table salt. And I'm just going to do table salt because it's an easy example. And that will be it for today. The stuff that you have on potato chips to make them so addicting, pretzels, it's in a lot of food. So we typically just call it sodium. Table salt is actually called sodium chloride. And that is NaCl. That is the chemical formula for table salt. The same stuff in pretzels, on French fries, on potato chips, you name it. It's very addicting. We love salt. It is composed of 1 sodium atom and 1 chlorine atom, 1 of each. Here's how it works. Here's sodium. 11 protons, 11 electrons. Please draw it. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. One. And you guys have already said correctly, sodium has 1 valence electron. So the next question I'd like to ask you is it stable by itself? No, easy. Okay, use a different color and make chlorine. Chlorine has 17 protons, 17 electrons. Please draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Third energy level. 1, 2, 3, 4, 5, 6, 7. Okay. I need you all to be looking at the periodic table while I ask you this next set of questions. I want you to look at the transfer electronegativity. I want you to look at the transfer electronegativity. Here's an easy question. What element is closer to fluorine, the strongest of them all? Chlorine or sodium? Which one is closer to fluorine? What? Which element between chlorine and sodium? Sodium is Na, not S. What element is closer to fluorine? Chlorine is. Chlorine's right there underneath it. Do we all see that? Okay, so which element is more electronegative? Chlorine or sodium? Which one, Connor? Chlorine is correct. So, based on the definition of electronegativity, Connor, is chlorine more likely to be an electron taker or an electron giver? It's a taker. How many more electrons does chlorine need to be stable? One more. Can you predict where it's going to get that one from? Sodium. So here's how it happens. Chlorine is located, if I go up here to the periodic table, guys, chlorine is located right here. Sodium is located right here. According to the trend, chlorine is more electronegative. As I wrote down here, the more electronegative element takes electrons, the less electronegative element gives or donates, whatever word you want to use. So here's how this works. This is going to be a win-win. Watch. Don't miss this moment. Now, what is chlorine's new electron number? 18. What is sodium's new electron number? 10. What is sodium's charge now? +1. Thank you for not just saying positive, Madeline. You said +1. What is chlorine's new charge? And do you remember what I told you do with the names of the negatively charged ions? It's no longer called chlorine. What is it called? Chloride. And in the whole science of chemistry, what attracts what? Opposites attract. So the chloride and the sodium be attracted to each other because one is positive and the other is negative. And this is going to form sodium chloride, which is a compound. They're bonded together because they are attracted to each other. A positive ion is attracted to a negative ion. This is what we will start to do in Unit 6, beginning Monday. Learn how things actually bond together. So for any of you that might have been wondering, where does sodium's electron go? Or where did chlorine get that electron from? Matter cannot be created, nor can it be destroyed. An electron doesn't just go poof, gone. And an electron doesn't just go poof, here I am. It's got to come from somewhere and it's got to go somewhere. This is where they come and go. There's takers like chlorine, and there's givers like sodium, and they form a bond because they're oppositely attracted to each other. One at a time. Ben.
What happens to one that like loses 4? Like, where do they make that?
Loses 4. So you could have maybe, how about this? What if you have carbon here? Remember, carbon was a +4 charge. What if it was attracted to 4 fluorines? Each of them needs one more electron to be stable. So you get multiple bonds like that. So one electron goes to fluorine number 1, then fluorine number 2, fluorine number 3, fluorine number 4. And you'll have 4 bonds. Yes. Not this test. This is just a preview for Unit 6, okay? I wanted to just answer the question. Some of you were texting me like, when I told you chlorine goes from 17 to 18, somebody said, where does it come from? It comes from an atom that lost it. Some of you are saying, where does that electron go? It goes to the more negative one. So you'll see a lot more of this in unit 6. Okay. Are there any further questions? Yes, Tristan. Sodium, okay. He's asking, can sodium work with fluorine? Absolutely. If you had sodium here, sodium has a positive 1 charge, fluorine has a negative 1 charge. They will come together and they'll form sodium fluoride. And Tristan, with your logic, you could do bromine, you could have sodium bromide, you could have sodium iodide, and you could also do other elements in the first. You could have potassium fluoride, potassium chloride, potassium iodide, because listen, how many electrons does everything in group 1 have to give up to be stable? How many electrons does everything in group 17 have to obtain to become stable? Sounds like a match made in heaven to me. You ever heard of the saying, one man's trash is another man's treasure? Sodium and everything else in group 1 needs to lose something to be complete. Everything in group 17 needs to gain something to be complete. So this is where some of the numbers games are going to have to work, and we'll work up with all the various elements that are throughout the periodic table too to get them to fit together. Just it's like addition kind of puzzle. You got to work with the numbers. Yes, for
So if it's like, if the sodium is positive and the fluorine is negative, then how come when you write NaCl you don't put the positive?
because they cancel each other out at a 1-to-1 ratio. So this is another great question. His question is, when I wrote sodium chloride NaCl or sodium fluoride NaF, why did I not write positive or negative? Because Varun, think of it like this. You got a positive 1 here. Whoops. You have negative 1 here. You put them together. What's the resulting sum? It's 0. So when it's 0, you don't write any charge. Okay. If I were to kind of just tease you guys with something a little more complex, look at this. Let me think of something. All right, watch this. Magnesium has positive 2 charge. Bromine has negative 1. Okay. This is not on your test, so just chill. What do I need more magnesiums or more bromides in order for these two to work together? How many more bromides do I need? I already have 1. I need 1 more. And so this is an overall positive 2. What are these two combined going to be? And what is positive 2 plus negative 2? And so the chemical formula would be MgBr2. That number just means, does that mean the charge or does that mean that the number of bromides? The number of bromides, that's right. We will work this out. This was just a little teaser. We'll start a lot of this on Monday. Okay,